All right, let's get started. So, wanted to kick this off with a question. Who here has read through Netflix's culture deck, read through our Glassdoor reviews, heard what it's generally like to work there? Sweet. Hopefully only good things. One of the things that we emphasize is candidness, since for a company like ourselves that values communication with one another, honest, candid feedback, you can see why candor is very important. Reed cites it in our new culture deck as one of the first top 5 unique traits about working at Netflix. Hopefully, if you've interacted with anyone at Netflix or seen some presentations, the level of candor and honesty has been relatively uniform, and that's actually what we're going to kick this presentation off with an alternate title. Why capacity planning sucks at Netflix, how we as the capacity planning team make it less sucky, and how regional reservations, which Amazon launched earlier this year, lowers the suck. So that's a technical finance term for folks. Rajan, who's kind of the brainchild on how we adopted regionals in 2017, he's going to go through the process on over the course of many months, problems we faced, the solutions that we implemented, and hopefully some learned lessons that are applicable for other folks in the room. But it doesn't make too much sense to talk about a reservation strategy without saying what our actual challenges are, because you're supposed to build your reservation strategy around your actual usage landscape. So I'll start with that. We're going to bridge the 2 sections about talking about what our team actually does, so you have higher level of context on how we approached everything. And there's actually a hidden 4th section, which is efficiency and capacity initiatives that we've worked in this year, and what we're planning on in the future, so you kind of get a sense on what we're trying to do in the future. All right, so I'm going to take a brief pause here. Hopefully this is what you've expected. If you read the abstract, if it's not jiving with your expectations, feel free to pop out to another talk. Otherwise, we'll get started. Cool. It's a 300-level talk, so I expect most folks here already know what reservations are, but I need to set a baseline just to make sure we're all starting from the same floor. So really, you're just trading a commitment to Amazon for a financial benefit and a capacity reservation. Pretty simple. 3 major dimensions. First is type. So standard is what most folks are familiar with. Subscribe to a particular availability zone and a particular instance type within a family. And then you can modify up and down the family sizes, and then also between the AZs for the region that you chose. Convertible, a bit newer, where you give up some of that financial benefit, and then you can hop over between different families and between different regions. And then scheduled, which is a bit more niche, where you get a capacity reservation for a certain time slot. And it comes on a reoccurring basis, and then there's a minimum commitment as well. Duration's much more straightforward. Longer, the cheaper the reservation becomes. And location applicability is also pretty straightforward. So zonal, you get the capacity reservation and the financial benefit within a particular AZ, and then regional, which is the new thing, you get more flexibility, financial flexibility, but you lose the capacity reservation. Okay, just to check our understanding really quickly, talked about you should be planning against your landscape. So say you want the latest and greatest. Standard 1 year, just refresh when the reservation expires with the new hardware, and then the hardware is kind of coming at a 1-year cadence now. Or convertible 3 years, and you just take a more active role in making sure you're converting them whenever the new hardware comes out. So pretty straightforward. Flip side, cost to a minimum, so your best is going to be a standard 3-year regional. But then you can also go down the convertible path and just upgrade to the newer gen hardware and then get the performance out of price performance benefits. So one final example, reserving for batch. The obvious one is use some scheduled instances, or you could do standard convertible zonals and then just play a much more active role in managing your reservation, swap it to other folks during the rest of the week, and then bring it back when you need the capacity reservation. Great. So hopefully we're all on the same page now for reservations. Let's flip to why capacity planning is challenging at Netflix. So we have a couple of bullet points here. If you kind of boil them up to the major categories, there's some complexities because of our business, because of the infrastructure choices that we had. We're also operating at scale, serving a lot of customers around the world. And then we also can't fail. So we set a very high availability goal for ourselves, 99.99%. And then that also has its own capacity implications. So 100 million subs, membership all over the world, served out of 3 regions. It's important for that third bullet that we're talking about everything before you press play. So the video streaming part of it, that's all on Open Connect, our own internal content delivery network. So we're not talking about that side of the house. Microservice architecture, and then lots of different devices. Some have different call paths. Let's make it a bit more tangible. Multi-account structure, why we have to bring that up is capacity reservation account is one of the dimensions, and it creates complexities when you start having lots and lots of accounts. From a stakeholder perspective, over 1,200 engineers on 90+ teams that we have to deal with. And that translates into 2,500 distinct applications. So I always love to show this hourly graph broken out by application, which we call the lasagna graph. So those are, each color represents its own application. And then application for us is one auto-scaling group. So that translates to over 175,000 reservations that we have to manage on a day-to-day basis. And then I talk about our high level of availability. So right now we have sub 7-minute regional failovers. So whenever one region goes down, we just evacuate it, go to the other 2. From a capacity perspective, that means if you just have organic growth of a critical service in one region, you have to ensure that the other 2 regions can support that failover. So it gets a bit tricky. Feels a little overwhelming now. I'm going to toss in one more monkey wrench that's going to hurt. Freedom and responsibility. So before we go into the bullets, I'm going to take a step back, talk about Andy Jassy's keynote from 2016. Talked about superpowers. And like cloud, AWS gives engineers superpowers. Well, that's great. What happens when you have someone with superpowers that has like the wrong intentions or they don't have the wrong context? Then they turn into supervillains. So internally at Netflix, our job is to give folks the right context, and we kind of act like the Uncle Ben's, hopefully not falling into the similar fate of what happened to him. But we say things like, with great elasticity comes great responsibility. So that applies to the first 2 bullets. Those are actual quotes or statements that were made in 2017 that we had to chat with engineers about. So the first one was a scale test on our internal container platform. They wanted to see how many endpoints they can spin up in one availability zone. The second one was our largest Elasticsearch cluster doing a redeployment, which internally we call a red-black, but it's gigantic. So it's pretty expensive. So where this all stems from is from our culture. We believe we hire fully formed adults, put as little rules as possible. So for the 1% of bad actors, we're not going to throw in all these crazy rules, and then it's just going to limit innovation for everybody else. So instead, hire a bunch of great adults. Hopefully we have no bad actors, and then have no rules. And then innovation should work pretty well. So in the end, on the third bullet, it means anyone has the freedom to take out Netflix, but hopefully they're responsible enough not to do so. So I know it feels even more kind of overwhelming now, but I'm just going to prove that it's actually possible. We showed this back in 2015 during an efficiency reInvent talk. This is our key performance indicator when it comes to cloud infrastructure costs. So it's cloud infra costs over total number of streams. We try to keep it flat with the exception of that one spike you've seen. It's relatively flat. We showed it up to October in 2015, and then now we extend out the line, so we're still doing pretty well. So let's dive more into what we actually do to make sure this line is flat. So capacity planning team at Netflix, cross-functional group between performance engineering, financial planning and analysis, which we're both a part of, and then data science. Our charter, I'll read it verbatim, is ensure availability of capacity in an efficient manner so other folks can further prioritize innovation, availability, security, and privacy. So during yesterday's Tuesday Night Live, they talked about undifferentiated heavy lifting. That's essentially a longer, more elegant way of saying it, where we just centralized all of the capacity operations and all of the efficiency focus on our internal team so engineers can focus on what they do best. Most of what we do fall into 3 major buckets. First is setting context, so making sure folks have the right capacity or efficiency context. That's the Uncle Ben part. Managing capacity through reservations and ensuring that any particular service that needs its necessary capacity, they get it. And lastly is driving efficiency. So in Q4 of every year, we get together, have an on-site, plan out efficiency initiatives that we're going to pursue for the next upcoming year, since it's kind of difficult having so much decentralization of our usage for us to maintain that efficiency KPI without us actually doing something about it. So where does reservations fall in this whole landscape? It's between managing capacity and driving efficiency. I'm going to go over it at a super high level and then pass it off to Rajan, who's going to go into the weeds. So pretty simple, 3-year zonals, purchase at a weekly cadence before regionals. Now we've added regionals into the mix. 3 main tenets when it comes to purchasing reservations. So first is buy only what we use. So when we scale up into on-demand, we verify whether or not it's real usage. And then if it's sustained, then we're going to purchase a reservation against it. We're trying to minimize that time window as much as we can after we verify and then purchase. And then hopefully in the future, that's all automated and it's like happening within the hour. Secondly is buying for peak usage. So as you can imagine, Netflix is extremely seasonal. So people watch more during the holidays than during normal days, weekends versus weekdays, nights versus mornings. And we have a lot of big critical streaming services scaling up during that time. So we need to ensure that their resources are available when they scale up. So weekly cadence is pretty good because we got some seasonality going into every weekend. Lastly is buying into a few instance families and types. So we try to aggregate it as much as possible, one, to reduce overhead for our team because there's so many dimensionalities when it comes to a capacity reservation. And secondly, when you consolidate as much as possible, there's just some benefits like, you're auto scaling up, but you're still under your reservation line. Some other service redeploys during that time frame. That doesn't go into on-demand. And then there's kind of these small benefits that help us over time. Great, so without further ado, pass it off to Rajan.
All right. Thank you, Andrew. Before I dive into how regional RIs can help lower the suck, let's first level set on what the difference is between a zonal and a regional RI. Andrew touched on it a bit, but let's really crystallize that. So a zonal RI carries a capacity reservation and is tied to both an instance type and an availability zone. Note that while the financial benefit can be shared across linked accounts, the capacity reservation cannot. It's only good in the account in which you purchase it. Regional RIs, on the other hand, do not have a capacity reservation and are both instance size and AZ agnostic. Similar to zonal RIs, you can share that financial benefit freely across linked accounts. To sort of crystallize what we think is one of the main benefits of regional RIs over zonals, the operational simplicity, let's walk through a quick example of how we actually cover usage. Using EUS1 and the M4 instance family as an example, let's say on day 1 we have a usage pattern that looks like this. 3 M416XLs, 1 in each zone. To cover this in a zonal world, we would purchase 3 M416XL zonal RIs like this with the red outlines. But at Netflix, we have a relatively high innovation engineering culture, so our usage patterns are always changing. So let's say on day 2, the usage pattern looks like this. Now we'd be running 2 of our 3 services on demand until we make this very manual modification. And to go to the extreme, let's say on day 3 that usage pattern changes again. 2 of those M416XLs move out of zone C, and the third one splits into a fun spattering combination of instance sizes and AZ combinations. Now we'd be running 100% on demand as well as being billed for those 3 unused zonal RIs until we notice this and make this very manual, very sort of intensive modification like this. But thanks to regional RIs, things have become a lot simpler. Using that exact same example, you just simply purchase 3 M416XL regional RIs, or whatever size equivalent you want. It could be 48 M4XLs. And even as our usage pattern change, there's no additional effort on the cloud capacity planning side to actually change anything. So we're all good, even in this sort of crazy scenario that I've taken to the extreme. No additional operational overhead. So this is really what we think is the beauty of regional RIs. Zooming out of this specific example, the Netflix reservation and instance usage landscape is actually quite a bit more complex. We primarily operate in 3 regions with 3 availability zones each, and we mainly use 35 instance types among 7 instance families. And we also hold the bulk of our reservations in 5 main accounts. If you multiply those dimensions together, you get something kind of crazy like 1,500 RI configurations to manage, purchase, and modify, which can have myself, Andrew, and Adam thinking, well, we'll just sleep when we're dead because we're just spending our entire day modifying reservations as our usage changes. And we don't get to do any interesting work like analytics or think about our strategy. Thankfully, regionals has made this a lot easier, so that we effectively kill the AZ dimension, we kill the instance size dimension, and we kill the account dimension because there's no longer capacity reservations that you need to worry about. This gives us a much simplified purchasing matrix and RIs to manage with region across the top, and instance family down the rows for a total of 21 RI configurations. That's nearly 2 orders of magnitude improvement. We like to think of that as the capacity planning equivalent of achieving Tomorrowland or AWS Replay DJ success, but unfortunately, we're not in this ideal end state yet. Nor do we think we're going to be a completely we're not going to be a completely regional RI shop anytime soon for some reasons I'll talk about later. But we have made significant strides in adopting regional RIs, and now a significant portion of our RI footprint is in regionals, and we like to share our story with how we actually did that. Earlier this year, before we adopted regional RIs, we were a completely 3-year zonal RI shop. Andrew touched on this a little bit, but our primary focus was to purchase enough capacity reservations to cover our critical auto-scaling services peak instance usage. And our secondary focus was that financial benefit that comes along with a 3-year usage commitment of a reservation. Secondly, since we have a very high innovation engineering culture and we have people asking for 2,000 M416XLs for a few days period, there's naturally going to be some usage that we are not going to cover with reservations just because we'd have a ton of unutilized zonal RI. So we ran a low single-digit % of our instance hours on demand, which at our scale can be pretty expensive. Also, since we're covering both prod and test usage with zonal RIs, we go through this exercise of modifying reservations all the time, and that's a lot of operational tax for us. Once we understood some of the benefits of regional RIs and how they might help us alleviate this operational tax as well as reduce our costs, we wanted to develop a framework for how we'd think about which services to start covering with regional RIs. We boiled that down to 2 dimensions. We look at a service and we ask ourselves 2 questions. 1, does that service auto-scale, or is it pinned at a certain level? Is it stateful? And secondly, is that service streaming critical? Meaning if that service were to fall over or run into any sort of capacity issues, would it impact our subscribers' ability to stream? In the first phase, we took the most conservative approach. We went for non-auto-scaling services and services that weren't streaming critical. You can think of this as Elasticsearch and Cassandra test clusters. This is also where we just wanted to get our feet wet with regionals and see what it'd do with our tooling. Once we had that baseline level of comfort, fixed our tooling a little bit to ingest regional RIs, we moved on to see how it would react to auto-scaling services. Still non-streaming critical. You can think of this as our internal IT applications that we all just flipped over to regionals, as well as just some stateless test clusters. After that, we had enough confidence to start actually covering some of our critical service usage with regional RIs, non-auto scaling. So you can think of this as our persistence prod tier, things like Elasticsearch, EV Cache, and Cassandra. The thinking here is that those types of stateful services scale very incrementally and very rarely, if ever, do emergency red-black deployments. So even if we were to run into a capacity crunch in one of these instance types, it's very unlikely that it would be streaming impacting. And lastly, we went all out and modified a portion of our zonal RIs over to regionals in our main production account that holds all of our streaming critical stateless services there. At each one of these stages here, at our scale, we were modifying thousands of reservations, tens of thousands of reservations. So a natural question is, how do we actually execute those kind of modifications at scale? Of course, we use the AWS Web Console. This may be a familiar site to some people, but for those who have not used it, you log into the AWS website, you select an account, and then you select a region, and you get a full sort of inventory of all your reserved instances in that account and region. Here I've selected 2 in our main production account, 2 M416XLs and US East 1, C and D. If we wanted to modify these 2 reservations over to regionals, we would select, pointer doesn't work, we would select the scope drop down, click on region. We'd do the same for the second one, and we'd rinse and repeat thousands of times. So it's a pretty scalable solution, right? Wrong. This is totally fake news. We did this for the first few, and then we realized this is not at all a sustainable solution. So what we really did is we used a tool called Libra, which is something our data engineering partners built for us. And it essentially abstracts away the need to select individual lease IDs to modify, making batch modifications really simple. And the way that this works is it essentially asks for a modification. You give the details of the modification. It looks at our entire RI inventory, and it selects the optimal lease IDs to modify. And there's some really cool advanced features like automatic retry logic. So if any of the sub-modifications of the master modification fails, you can actually retry the entire thing with just a single click. Let me quickly walk you through the UI here. You select the instance family, instance size, and region, as well as the account on the top. You click Show Graph, and you get all the AZ and instance types that you've selected. Note that the -- AZ corresponds to regional reservations. The red lines in each of those graphs corresponds to the RI inventory, and the gray area is the actual instance usage. To make a modification, you select the instance type and AZ combination you want to modify. Let's choose M4XLs and USC1C. Click on that button there. Modification panel comes up asking you for the details. We're going to keep the same networking type in this case, keep the same size. We're going to change the zone to --, which I mentioned is regional reservations. And we're going to select a quantity of 10, but you could easily do 100 or 1,000, and the user experience is exactly the same. Libre takes care of everything on the back end. Does this sound like something people would be interested in potentially open sourcing? Does this sound useful to anyone? OK. Sebastian's in the crowd, so you have your answer. No promises, though. So up to this point, we had developed a framework of which services to cover with regionals. We did a bunch of modifications from zonals over to regionals. But the next natural question for us was, what is the right number of regional RIs? How do we really minimize our EC2 bill with this very flexible reservation? To answer that question, we built a brute force simulation or an optimization engine, which at a high level looks at our instance usage over a fixed time period, looks at our reserved instance inventory, runs that brute force simulation of every possible regional RI inventory we could have had over that period, and it outputs a net RI recommendation, regional RI recommendation. Keep in mind, I'll walk through some of the major steps that we do in this optimization, but all of our input tables are stored in Hive on S3, and all the data processing is done on Spark. So we start out with two tables, our RI inventory and our historical instance usage over a certain period of time. It could be 24 hours, 5 days, 7 days. It really depends on what your usage patterns look like. The next step is to, and this is specific only to folks who want to maintain both zonal and regional RIs. If you just want to be a purely regional RI shop, you can skip this step. But since we do care about zonal RIs and those capacity reservations, this is a step we had to do. So what we do is we first remove all zonal RIs and all usage covered by those zonal RIs. The idea here is that those zonal RIs are there for a reason. They're there to provide capacity reservations for critical services peak instance usage. And we're unwilling to compromise those capacity reservations in favor of additional financial flexibility. So we take those out. The next step is we normalize at the instance family level to the .xl size, and we aggregate at the region level, since these are the two dimensions that you purchase regional reservations for. And as I mentioned, if you don't care about zonals, you can just skip straight to that step. Next, and this is the meat of the simulation, is we look at every single instance, family, and region combination. We look at the range of instance counts over our time window, and we simulate a regional RI inventory for every single count in between that range. It's a bit of a mouthful, so let me show you what that actually looks like in a very simple example. Using M4s and US East 1 over just a 4-hour time period, say we had usage counts that look like this. Hopefully you can read that. The range is 5 to 9. So we would run a simulation as if we had 5 regional RIs over that time period, 6, 7, 8, and 9. So you basically blow this table out and you run 5 simulations. After that, we join in all of our pricing, so both on-demand as well as our 3-year RI pricing, and we calculate the cost of every single simulated regional RI inventory. It's really 2 steps in one. So first, at the hourly level, we calculate the cost, and then we sum up for every single regional RI simulation what the total cost would be. So you can delete the hour and the instance counts to get this aggregated table in the bottom right. Next, you just run a simple minimization on that cost column, which is the far right column, to basically output your optimal number of regional RIs, which in this case is 7. And lastly, you net out your current number of regional RIs to get a net new regional RI purchase recommendation. And now you have all the information to calculate things like estimated annualized cost savings, which you can throw over to your finance team and they'll be happy. Note that we understand that this is a sort of reactive optimization engine. And though it is reactive and not predictive, we think there's a ton of value here, and we've saved millions of dollars from using this. That said, in 2018, we are trying to get a little bit more predictive. And largely, we'll be using the same sort of framework. We're just going to do a fair bit of pre-processing to get predicted instance usage instead of historical instance usage on the far left. And the way we're thinking about doing that is we're correlating individual services growth with some of our key business metrics, which is stream starts as well as subscribers. And we have a team internally that provides a pretty robust forecast of where those 2 metrics are going to be based on our content release schedule and general seasonality of our business. And we can apply those forecasts to individual services depending on what's most correlated to get to predicted instance usage and feed it through this exact same optimization engine. So that's something we're really excited about for 2018. Hopefully all this makes sense in theory, but we want to show you that we really were saving money at each one of these steps, and it's not just good in theory. So let's look at hourly on-demand cost over the 6-month period where we adopted regional RIs. And you can see the blue area corresponds to on-demand cost. The orange area is unused zonal RI cost, and the green area is unused regional RIs. Up until this first point here, we were a completely zonal RI shop. So you can see we were incurring a fair bit of on-demand, as well as we had some unused zonal RIs. This is just pure waste in our mind due to slight mismatches between our instance usage and our reservations. So when we were testing regional RIs, it was really easy for us to just flip all those unused zonal RIs over to regional RIs and see what would happen. You can see on-demand goes down pretty nicely, as well as those unused zonal RIs go away. A few more weeks go by. This is where we sort of fix some of our tooling to ingest regional RIs. And even in that few-week period, you can see that our usage patterns have already changed. Unused zonal RIs show up again, and our on-demand creeps up. At this point, we do a secondary cleanup of all those zonal RIs over to regionals, and we make a small but relatively uninformed regional RI purchase just to curb on-demand. You can see both on-demand goes down as well as zonal RIs again, unused zonal RIs. And over the next 2 months, we developed that regional RI recommendation engine, and at around month 3, we had enough conviction to actually put our money where our mouth is and make our first purchase informed by that algorithm. You can see on-demand now basically goes to 0. And there's a very small layer of unused regional RIs, which is to be expected because of the huge cost difference between a reservation and on-demand. It's important to note or reiterate that our purpose in adopting regional RIs was really to reduce operational complexity, reduce cost, and wasted resources. We recognize we're not going to totally eliminate on-demand just because some of our large-scale tests and frequent, large, but very short service deployments on a daily basis. It's just more efficient to cover with on-demand. One unexpected benefit that we got from regional RIs can be seen in our Trough borrowing ecosystem. Those who may not have seen Andrew's 2015 talk may be unfamiliar with the Netflix Trough. But given that many of our large critical services auto-scale, and we purchase zonal reservations for peak usage, during non-peak streaming times, there's naturally a large pool of unused resources that we can allow certain internal services like our encoding team to opportunistically borrow, essentially for free. For those who may be interested in actually supporting your own Trough, there are a few things you need to have in place before you can actually allow people to start borrowing resources. The first is you must have a centralized source of truth for all available resources. This is handled in our case by Spinnaker, a continuous delivery platform. Roughly every 5 minutes, they look at our entire reservation landscape and all of our instance usage, and they calculate the amount of available resources by AZ and instance type, and they publish that to their reservation API. All the Trough borrowers can hit this API, and they can see where the available resources are to help inform their borrowing behavior. The second thing is you need to have some generally agreed upon borrowing behaviors or rules with all of your Trough borrowers. The first and most important for us is every Trough borrower must have a big red button that they can press at any time to evict all of their currently borrowed resources. The thinking here is that if anyone is borrowing on the same instance type and AZ as any of our critical services, if our critical services run into a capacity crunch, we want those borrowers to be able to evict themselves very quickly to hopefully release those resources back to the general pool that then our services, critical services can grab. The second thing you need to think about is how to divide up resources if you have multiple Trough borrowers. The simplest example of this is earmarking certain resource pools for certain services. For example, we could say encoding, you can only borrow M4s and US East 1. And we could tell our recommendations team you can only borrow R4s and EU West 1. This is something we've done before, and we don't think it's a great solution, but it does work. Ideally, you'd be able to have multiple Trough borrowers borrowing the exact same resources. And this can be done by having a centralized Trough broker, or ideally, this is going to be done by our container runtime platform, which is already dividing up resources among different borrowers. So they would just ingest the entire Trough and give it out to everyone. Some added bonuses from Amazon this year that have made Trough borrowing even sweeter are regional RIs and per second billing. So Trough borrowers really love regional RIs because of the flexibility, right? So the size flexibility allows them to now choose an instance size that more naturally fits their workload, and the AZ flexibility gives them 3 shots at getting the capacity that they need. Per second billing is also sort of given them more confidence to borrow up to 100% of the available resources. Before per second billing, if they went slightly over just for a few minutes of our RI counts, they would be penalized with an entire hour of on-demand. But with per second billing, you really only pay for what you use. So they have a lot more confidence to borrow closer to 100% of the available trough. On the right-hand side of this, we just wanted to give an update of what our trough borrowing landscape looks like today. The blue area is vCPU hours consumed from zonal RIs, and the orange area is vCPU hours consumed from regional RIs. To give you a rough idea of the timeline here, we first adopted regional RIs there. About a month later, Spinnaker rolled out support for the reservation API to show available regional RIs to borrow. And about a month after that, each individual borrower had to adjust their logic to now understand Spinnaker's new API before any trough borrowing really began. Today, nearly a third of our trough, our used trough capacity is from regional RIs. And to give you a sense of scale, at peak for regional RIs alone, we've eclipsed 500 million vCPU hours on an annualized basis. After our initial adoption of regional RIs, here's where we are today. We operate a heterogeneous reservation fleet, so we have both regionals and zonal RIs. In the span of 6 months, we went from 0 to over 50,000 .xl normalized regional RIs without incurring a single capacity-related streaming outage. We've also cut our on-demand costs by about 30%, and perhaps most importantly, we've decreased our operational overhead, or the amount of time actively spent modifying, managing, and purchasing reservations by 50%. Looking to the future, we're really focused on two things. One is we want to get smarter about how we're purchasing. As I mentioned in the regional RI optimization section, we want to now see where our usage is going to be in the future and purchase for that, so being more predictive. And we also want to start now reducing the amount of human manual intervention needed to execute purchases. An example of what this might look like for 2018 is being pushed regional RI recommendations via email or Slack, and within 1 or 2 clicks, having a human be able to execute that purchase. So semi-autonomous, we're getting there. And secondly, given we're in this unique position where we have both a fleet of regional RIs and zonal RIs, we now want to start dynamically managing the balance between the two. An example of what this might look like is before any sort of tentpole content releases or international holidays or any other time we might expect a strong uptick in streaming behavior, we would temporarily move a slew of our regional RIs over to zonals to give our critical services additional capacity reservation buffers. And lastly, to close out this section, for those who now may be interested in adopting regional RIs, here's a short summary of this entire section of some takeaways we hope you keep in mind. One is create an adoption strategy. Our 2 dimensions of looking at criticality and auto-scaling versus non-auto scaling is one way of doing this, and it's definitely not the only way. Think about what makes sense for your company and what will work well with your culture. Secondly is, at first, don't bet the whole farm on regional RIs. Start small. You're likely going to run into a few unexpected issues you didn't think about before, and they're going to be a lot easier to solve and work through at a small scale. And once you have that baseline level of comfort, you can quickly accelerate your adoption. Third, and this is potentially most important, is invest upfront in tooling. If you currently don't have a tool or a solution that allows you to optimize and manage your RIs, we highly recommend purchasing a solution or building your own in-house. The tools our data engineering partners have built for us, like Libra, have provided us tremendous leverage and have paid for themselves easily 100 times, 1,000 times over. And lastly, if you remember nothing else from this section, remember the 2 key value propositions of regional RIs. They save you time and they save you money. I'm going to throw it back over to Andrew now, who's going to close it out with, at a high level, where we're headed from an efficiency point of view, as well as talk about some of our capacity initiatives.
Thanks. So what's next? And in line with what we mentioned at the beginning of the talk, it's tackling the future suck in both a capacity and efficiency standpoint. Throughout this section, we're going to be using a ton of car metaphors, so please bear with me as we go through each. The first, we're going to talk about car sharing. So I'm going to take a guess here and say if everyone had to sell their cars that they own today and then they had to repurchase into whatever form of transportation that they need on a daily basis, I think general car ownership would actually go down. Main reason being a bunch of the car sharing services that have appeared over the past few years. So now you can, instead having your own car, just use Uber or Lyft. Take you around. Or in a more futuristic state, you could have a car that autonomously drives you to work, and then it can be in like Uber mode, drive other folks around, so you're sharing your car resource, and then you can pick it back up in the evening when you need it again. The parallels I'm going to draw here are related to capacity and resource sharing for whatever service that you're running in the cloud. And then I'm going to also link this with Trough borrowing. So, for availability purposes, they talk about treat your instances like cattle, not pets. But when push comes to shove in the actual world, folks don't really like to give up their non-critical services and the capacity that they're holding. Our first team to actually break that notion completely was the encoding team. So this was a pro tip slide from 2015, where we had this one recommendation service scale up over 1,000 R3-4XLs. And then they only needed it for 12 hours of the day. So we were hunting for other folks who could use that other unused trough, and we found the encoding team. It was very primitive trough borrowing, where it's just you get the first 12 hours, I get the next 12 hours, that's it. That equated into 6 million instance hours for the encoding team, and it was like their gateway drug into trough borrowing. So after that, they certified themselves over more instance types, more regions, made their jobs more interruptible and shorter duration in nature. And today, they're consuming over 120 million instance hours annualized in a completely automated fashion. So literally, almost all the encodes that you have on every single Netflix device is being run inside this Trough. So it's theoretically for free for us. Now, that's great, but what's the future for this? Well, actually, we could borrow up to 650 million instance hours. So right now, we have a short supply of Trough borrowers. And it's that original notion of resource sharing, where we need to go to service teams and be like, hey, can you please make your service more interruptible, shorter duration, give up the capacity when you don't need it. So this is more of a general PSA that if you have these kinds of services and you're entering AWS, or they're kind of reluctant, please convince them to do so, because it's just going to pay a huge amount of dividends later. A nice tailwind that's occurring in the general cloud industry right now is containers. So that's our logo for Titus, our internal container solution. And as jobs enter containers, the issue of eviction and prioritization is like a natural conversation you have with these teams. So when you're having these conversations, try to convince them to adopt those traits that I mentioned if they're non-critical, and hopefully you'll be saving a lot of money in the future. So right now, our container adoption internally is in its infancy stages, so we'll hopefully have an update for you guys next year. Switching gears a little bit, we're going to talk about dashboarding. So I have to give credit to JR over at Cloudability, because this is a metaphor that he used in one of his summit presentations. So when it comes to driving a car, dashboard's just giving you feedback about how you're driving. This is a pretty old car dashboard, and it's probably also a pretty terrible car dashboard, given, just look at the speedometer alone. It's not even intervals between all the speeds. And why would you need to know more nuance between 90 and 100 miles per hour versus 40 and 50? That doesn't make too much sense. The fuel gauge, not telling you that much. Temperature gauge, sure. But through many iterations from car manufacturers, we see car dashboards like this today. So let's talk about the speedometer. At least it's even, so that's a plus, that's a win. From a fuel gauge perspective, now we have things that calculate your miles per gallon, or the remaining number of miles that you have. Or there's even colors that show you how efficiently you're driving, which is way better feedback than we had before. And then there's whole new realms of context, which is like a navigation system or temperature control. So the parallels I'm going to draw from this one is for our cost and usage dashboards, which for our engineering teams, we're giving them feedback on how they're doing in the cloud, or for ourselves, for our cloud infrastructure as a whole. We've just been slowly iterating over it over a long period of time. Now, I have to take a brief sidebar here, because as I was creating these slides, I actually came across this car, which is the 1979 Volvo Tundra prototype car. And what I just had to point out was how futuristic its dashboard is. So that's a speedometer, tachometer, also shows your gearing, and also shows your RPM versus your speed all in one graph. So in other words, if you have a cost and usage dashboard that looks like the Volvo Tundra, then you can just tune out for the next 3 minutes, because you're already set. You're in a good place. So bringing it back on topic. So this was our first cost dashboard that we released internally. Not too much going on here. At the top, aggregate cost. In the middle, you have business context. At the bottom, 3D bar charts on a time series. So just on the 3D bar chart alone, you could probably scrap this dashboard. The issues was it was way too granular, and it actually didn't tell you what of your services were growing. Now, during the same time period, we had a higher level dashboard for managers and directors that had our cost per stream broken out by the major sub-functions internally. But then we had managers and directors coming up and saying, hey, I'm 0.005213 of cost per stream. Like, am I doing a good job? Honestly, we couldn't tell them at all. So we decided to merge these two and create a more simplified dashboard, which we presented at 2015's reInvent. So on the left, usage, on the right, growth, bottom, time series, and then we added some business context that we had to scrub for this presentation. So much more simplified, and it did us well for 2 years. But over time, we found like it wasn't adding platform costs, or it wasn't using all of AWS's service costs. And we want to give people more and more accurate and more timely information. Brings us to V4. So let me set up the dashboard first. Very top, total usage. Right under is 2 of our main business metrics, which is stream starts and number of subscribers. In the graph, we're showing on the x-axis the nominal size of your service. The y-axis is the period over period percentage growth, and then the size of the circle is the nominal dollar growth over that same 2 time periods. And then we add some business context lines in red and in black. So immediately, your eyes should be focused on the biggest circles that are above the red and black lines. And then the further to the top right, the more concentration you should have on those particular services. So first, what we added, a lot of business context. Second, we added more platform costs. So we've seen like the rise of platforms at Netflix, whether it be data pipeline, our Hadoop jobs, our internal monitoring solution, Atlas. And people are kind of like throwing their workloads into these platforms, and then they're like, hey, my costs went down. It's like, no, that's false. So what we did, we took these platforms, figured out a metric for each platform about what's a good representation of their usage, and then just applied that against their EC2 costs, and then did some light tagging, and then reattributed out those costs. So we're giving people a much more holistic view of their actual usage and costs. Lastly, these are just 2 of the point of views that we have inside our new set of cost dashboards. There's over 10 of them that you could individually subscribe to. So just more versatility for managers or for individual engineers or for VPs to subscribe to, so they are getting the right and proper context. So let's actually pump the brakes for a bit and then talk more at a higher level. So like driving with feedback manually, sure, that's great. But where do we really want to go? We want to go more towards automation. So we're going to use a driving on the highway example here. So right now, it's driving, everything's super manual, look at your mirrors. And the future state, what Rajan talked about, is a ton more automation, where you're just touching the wheel every so often, and then the rest the car handles for you. So we are pretty far away from that, so we're not going to talk about our automation goals, but there's this intermediary stage that we're at today, which we're going to call smart alerting. So if you have a car within like the last 5 years, say you're driving on the highway, you take a left, there's a car there, either your driver's side mirror will flash at you, or there'll be a noise, and that's what we call smart alerting. So you only get context when it's applicable. Well, one of our specific use cases internally is related to when we have on-demand spin-ups. And now we get these nice daily email digests that show, like, OK, M44XLs in US East 1C is the primary offender. And then you can click in and drill in to figure out what that actual usage is. And we're just going to slowly automate more and more parts. And then eventually, hopefully, we'll just get to full-blown automation. So we have alerting set up. For this, we have alerting set up for like performance degradation at like the resource level. And we're going to hopefully set up enough alerts and then just slowly automate all of them to get us to our future state. Great. One last car metaphor. Hopefully, you guys are still with me here. This is related to washing your car. And then this is going to be the stretchiest metaphor of the bunch. So you're driving along down the road, and then you see like a rust bucket, and you're like, oh my goodness, that looks terrible. How did that car get to that state? Well, it's actually dust and moisture is the primary 2 offenders. So what happens is dust falls on your car, moisture kind of locks it in place, and then over time there's just micro abrasions. First on your wax, degrades the wax, then on your paint, degrades the paint. And once it hits the metal, that's when nice cars like this turn into rust buckets like this one. Now, why I said it was a stretch metaphor is I'm going to bring that with data growth. You can imagine we haven't been really washing our data for a very long time, and now we're reaping the whirlwind. So in the end of 2016, one of our largest projects for 2017 was figuring out how we could tackle our data growth, because we were having like some Hadoop clusters this year just grow 10% week over week, and we had no idea what was going on. So at Netflix, you can bucket data into 3 major buckets. First is data in motion, data in process, and then data at rest. And then these are the various technologies that we use, either built in-house or we use off the shelf from Amazon that drive each of these data tiers. Now our issue is when we approach like that Hadoop team and say, hey, why is your Hadoop cluster growing so large? They're like, I don't have an idea, but talk to the Kafka and Flink guys that are pumping data in. They might tell you something. Then we talk to those folks, and they're like, we don't really know. Like we just have a self-service platform. People just feed us data, and we take care of it. So what we found out what we needed to do is just stitch everything together, and we created this initiative called Cradle to Grave, which is kind of data lineage plus hygiene combined. So when we have questions like, what is consolidated logging, which is kind of all the logging that's occurring at devices that we use to drive your recommendations or do A/B tests, first we can outline who the heck is actually using it. And then once we stitch all that usage and apply some dollars against it, how much is it worth? And then the natural question after is it worth value for the company to sustain this amount of data? So not super prescriptive here, because I'm sure your data infrastructure looks a bit different. And your data might not be at scale today where it's like, I don't have to worry about it. But just like not washing your car over a long period of time, it can just really bite you in the end. So for us, we're taking a 180 on our approach to data this year, and then hopefully other folks are going to start thinking about it soon. Great. So I'm going to bring it all back. We're kind of in the weeds for the past few minutes. I wanted to recap first just saying regional reservations on what Rajan mentioned. Test and invest. Hopefully it's relatively straightforward if you don't care too much about capacity, but there's still some dashboarding things that you have to figure out. But if you do care about zonal reservations, then go incrementally like we did, and then over 6 months you could have a good portion of your fleet converted over to regionals. But regionals and reservations are only one part of the strategy. We spent that entire third section talking about other efficiency and capacity related initiatives that are part of like our general cloud strategy. So internally what I like to say is don't let capacity happen, or don't let efficiency happen. Just be intentional. Otherwise, you build some of these weird or bad habits, and then it's just hard to jackhammer them out later. Going to go a little bit more meta now. Being cloud native, and then the tagline here is don't block it, unlock it. So every so often, it's important just to think about the processes that you have in place at your company. For us, when we talk to other companies and we say, hey, we have no procurement process, they're like, what? That's crazy. Like, why don't you have one? Maybe in the data center world, where you're actually constrained by how quickly you can physically put a box together. In the cloud, everything's pretty elastic. You saw that one person from our container team trying to spin up 2,000 M416 XLs. So we question, why do we have a procurement process in the first place if you don't really need it in the cloud? And then every so often, through our offsites mostly, we question about some of the processes we have internally and whether or not it still makes sense. So it's just important always to take a step back every so often and be like, why am I actually doing this? And then is it cloud native, or am I just kind of creating an artificial blocker that's a legacy from the data center days? Cool. So with that, we'll open it up to questions. Just a brief reminder, please fill out your surveys, and then we'll also be at the Netflix booth with other members of the cloud capacity planning team ready to answer questions as well. So with that, I'm just going to put a backdrop of some of the other talks we have coming up. And thank you guys for coming.